Yeah, we will start class now, everyone. Okay, good afternoon, everyone. Good afternoon once again. Okay, so today we will be covering this topic, which is solubility and solubility product. Okay, right? We'll try to cover this topic first, right? So that we can have a problem solving session one day, which is most probably on next Monday. Okay, and I hope all of you will get time to solve all the problems. Okay, okay then. Now, before starting this chapter, let's have a recall test. Everyone, before starting this chapter, let's have a recall test. Now, tell me, answer everyone. Buffer resists a change in pH when option A, base is added, option B, acid is added, option C, base and added both is added. Tell me what's the answer? Okay, most of you are saying C. Okay, let's see. Now, question number 2. A salt of strong acid and strong base undergoes hydrolysis. This statement is true or false? Yes, very good. Okay, most of you are saying correct answer, right? Third one, the total salt that has undergone hydrolysis by the time equilibrium is attained is called, tell me. It is asking about H, everyone. Okay, this is asking about H, right? Asking about H. So what H is called? Okay, it is asking about H, everyone. It is asking about H. Okay, there's a difference, right? KH and H are two different things. Okay, everyone, right? Now, salt of strong acid and weak base give dash solution. Salt of strong acid and weak base. So it is comparable. Okay, concentration is comparable here. Tell me, what's the answer? Tell me, everyone, what's the answer? Okay, very good. Let's see. Okay, very good, everyone. Fifth one, salt of weak acid and weak base. Salt of weak acid and weak base give rise to acidic solution always. This statement is true or false? This statement is true or false? Yes, very good, right? So most of you got the concept. Let's see the answers. The first one, a base or an acidizer, which is C. First one, C. Second is false. Yes, most of you said it is false. Third, it is degree of hydrolysis, right? I told you H is same as alpha, right? Where alpha was degree of dissociation, H is degree of hydrolysis, and KH is called as hydrolysis constant. Okay. Now fourth one, as you said, it will be acidic, and fifth one false. Okay, everyone. Strong acid and weak base, it will be acidic. Okay, right, Wes? Okay, right, everyone. Now let's start the topic, which is solubility. Okay. Now, as I told you, if you remember, if you recall, I told you that salts, right? We'll study salts in three types, right, everyone? If you talk about salts, right? If you talk about salts, wait, everyone. Okay, yeah. So if you talk about salts, we can say that salts of three types. We studied that when we talk about salt. Okay, when we talk about salt, we talk about three types of salt. Right, everyone? Tell me yes or no. Right? Wait, just give me 1 minute. Just, yeah. Okay, so first we will talk about just salt plus water, right? Which is basically hydrolysis. Okay, the second is salt plus weak acid, right? Salt plus weak acid, yes, right? Which was your buffer. The third will be soluble salts. Soluble, wait, I'll just adjust my writing pad, okay, because it's going like this, soluble salts, right? Now we have already studied this hydrolysis as well as buffer, right everyone? We have already studied these two, okay. If we talk about solubility, right, before starting solubility, right, wait, what happened? Okay, before starting solubility, right, I just want to ask you a simple problem, just simple problem. Forget about the solubility of salt and everything. I just want you to remember the concept of chemical equilibrium, as simple as that, right? That's what I want you to remember. Now, suppose I'm having a reaction. Just think about a reaction over here, right? We have a reaction. What happened? Okay, MgCl2, right? Suppose this is a salt, right? This is a salt. Now, if this will dissociate, now why this is different? Because it is present in a solvent, right? It is present in a solvent in which it is soluble, okay, right? It is soluble, okay. Now tell me, what will the product here? What will be the product over here? Tell me everyone, what will be the product over here? What will be the product? Yes, it will be Mg2 plus Cl2Cl minus. Agree? Tell me, agree? Yes or no? Yes or no? Now this is your soluble salt. So this is your solid. This salt is solid, which is soluble, right? And again, this will be either aqueous or it will be in some solvent, right? It will be in solution phase. Now tell me, suppose you take a mole, right? Suppose you take a mole. Will it matter? Tell me, will it matter what is the concentration of MgCl2? Yes or no? Tell me, will it matter what would be the concentration of MgCl2? Think about it and let me know. Will it matter? Yes or no? Yes or no? No, very good, right? So we won't, yes, we won't be worrying about, yes, we won't be worrying about the concentration of MgCl because it's solid. So it doesn't matter what happens, right? We don't have to worry about this. Okay. Now, doesn't matter whatever it is, it will, what will be the concentration or the number of moles of Mg2 plus? Suppose this is X. So the Cl minus how much? It will be how much? Tell me. Tell me everyone. It will be 2x. Yes, very good. Right, everyone? And the activity of MgCl2 will always be 1. Now, for this, what is Kc? Tell me, what is Kc? Tell me, everyone, what is Kc? Suppose this is the concentration itself. Then what is Kc? Tell me, it is concentration of Mg2 plus divided by concentration of Cl minus whole square, right? Because the concentration of MgCl2 is 1. Agree everyone? Basic thing, that's what we have studied in chemical bond, sorry, chemical equilibrium. As simple as that, right? Yes or no? Yes or no? Just raise your hand. If you understood this, just raise your hand. Right? Right everyone? Mansi, Saismuti, Sumaya, Nidhi is here, Sania, Akshay, Anjali, Samya, Imba, Vivek is here. Vivek, you were absent in last class. Anamika, Malik. Very good. Everyone is getting. Very good, Mansi. Right? Karishma is also here. Okay. Oh, everyone is getting. Very good. Now, Just think about this, right? If you write the value, if you put the value, right, we will get what? Mg plus concentration, Mg2 plus, sorry, is x into this Cl is 2x. So it is 2x whole square. So Kc will be, right, 4x cube. Agree everyone? Tell me, agree? Okay, Vivek, no issues. Just let me know, okay? Right, whenever you are going to be like absent, just let me know. Everyone, please let me know. Just drop me a message so that I can know, okay? Now, is there any difficulty in understanding this equation? Because if I tell you, right, I've already told you that in ionic equilibrium, right, we will study exactly the same thing that we have studied in chemical equilibrium, only the name will change, right? Now in this reaction, what will change? So this X, since it is solubility, right, this X will be termed as S, which is solubility, degree of solubility, right? Got it? That will be the first change. Second change, Kc will be called as Ksp, which is solubility constant. Okay, got it? That's the only change that will happen. That's it, nothing else. That's the only change. That's the only change that will happen in this case of reaction. Okay, everyone, right? Are you getting a point? Tell me, are you getting a point? Okay. Now, if you think about any other reaction, just take this example, AlCl3. Now, it should be a salt. Obviously, it is solid, right? Now, it will break into Al3 plus 3Cl minus. Now, it will be S and it is 3S. Now, tell me, what is Ksp over here? Tell me, what is Ksp over here, everyone? Please message, what is Ksp over here? Yes, very good, Koshi. Very good, Jasharan. Everyone should say, everyone, step by step. Concentration of Al3 plus, okay, into concentration of Cl minus, which is equal to S into 3S cube. Yes, which is 27 S to the power 4. Easy enough? Yes, Anisha, very good. Easy enough. Everyone is getting this concept. Very good. See, any concept is easy or hard depending on how you understand it. Okay. So this was the concept. Now let's go back, right? So again, first of all, what is S? So as we say, we have S, which is solubility of solute, right? Solubility of solute is solubility of solute in gram by molecular weight of the solute, right? So obviously it is just like concentration, right? Now, solubility product, which is KSB. KSB is called a solubility product. It is same as Kc, right? But depending on the reaction, because here reaction is this one in which salt is anionized, salt is dissolved, right, and break down into ions. Okay, everyone, right? Okay, now we know that, right? We know that according to law of mass action, whatever the reaction is, right, it will be product of product raised to their stoichiometric coefficient divided by product of reactant. Now, since this will be solid always, right, it will be 1, or you can just take it to the side as we did in Kw, right? Now, this is your Ksp, right? Right, everyone? Okay, now we know that Ksp is same as K. You can just treat Ksp as same as K. So all the properties would be same. For example, Ksp will not change when we change the concentration or solubility, yes or no? Tell me. Ksp will not change, right? If we change S or solubility, right? It will adjust itself. Means if I'm having Ksp as concentration of A plus into concentration of B minus, if we change the solubility of A plus, solubility of B minus will change, right? If you increase the solubility of A plus, solubility of B minus will decrease, so that Ksp should be constant, right? Ksp will be same as Kc, which means it will change only when temperature is changed. Okay, everyone? So this is what it has said in point C and D. Okay, right everyone? Now just think about this. This is about solution and solvent. This is about solution. Now, I hope all of you remember how many types of solution you have studied, right? Depending on the concentration. Tell me, you have studied this in class 9? Have you studied about this? Tell me. Just if you remember, tell me. Undersaturated, saturated, and supersaturated. Right? Undersaturated, saturated, and supersaturated. This was based on concentration only, Karishma. Okay, not the type, because we will be talking about only those solutions, okay, which which is pure solution. Okay, so undersaturated, saturated, and supersaturated. Now, what is the meaning of supersaturated, undersaturated, and saturated? Tell me, what is the meaning of saturated? What is the meaning of saturated? So can I say that saturated means equilibrium? Can I say that saturated means equilibrium? Means if a solution is saturated means it has achieved equilibrium. Can I say that? Just think about it. Why not? Just think about it. Why not? What's it? What's the basic definition of saturated? Saturated means, right? Saturated means no more solute can dissolve, right? Means no more salt can break down into ions. Okay, right? Got it? And obviously, that's the case of equilibrium. That is the case of equilibrium, right, everyone? So saturated, when you talk about saturated, which means it is in equilibrium. Yes or no? Yes or no? Tell me, yes or no? Right? Now, what is undersaturated? What is undersaturated? It means, right, still product can be formed, still salt can be added, right? Still it will be dissolved, right? Okay, right everyone? So if you understand by the concept of Q, suppose this is Q, right? The concept will still hold. This is Q, right? So for undersaturated, Q is less than KSP or greater than KSP? Tell me. For undersaturated, Q is greater than KSP or less than KSP? Because at equilibrium, we will have this product as KSP. Yes, very good, Karishma. Q is less than KSP, right? Q is less than KSP. Very good. At when talk about saturated, then I can say that Q is equal to KSP, saturated. And for supersaturated, Q is greater than KSP. Anyone have any issue in this? Tell me. Anyone have any issue in this? Tell me, everyone. Anyone have any issue in this? No? Okay, very good everyone, right? So we'll discuss. I was just talking about these because you should know how to relate the concept that we have studied. Okay, so we can say that, right? We have three type of solutions: saturated, undersaturated, and supersaturated. Now this is basically your Q, which is product of ions, which is Q, right? So in saturated solution, which is equilibrium, KSP is equal to Q, right? Now at this stage, right, both the crystal, which is your solute, right? Okay, and the dissolved solution will be in equilibrium. Okay, now if KSP is greater than Q, right? So which means more A plus and B minus can be formed. So it is still soluble, right? More solute can be dissolved. But if KSP is less than Q, which means, right, we have a supersaturated solution. So the reaction will go backward, which means these two ions will again recombine to form salt. which is actually a crystallization. Yes or no? Right? Yes or no? Right? You form crystal, and the process is also your precipitation. Okay? You will get the crystals and it will precipitate. Right, everyone? Right, everyone? So if I ask you, right, when the precipitation will occur, tell me, when precipitation will occur, if the product of ions, right, which is your Q, is greater than KSP. Got it, everyone? Got it? Got this concept? Just raise your hand. If you got this concept, just raise your hand. Okay, very good, everyone, right? Now, do you think that this is very hard concept, or you're getting? Everyone is getting? Very good. So see, the general expression, as I discussed, if you have a salt ax by, right, it will dissipate into x a y plus y b minus. Okay, right? Now, if we talk about KSP for this one, it will be x to the power x, which is again this concentration, into y to power y, right? Y to power y into s to power x plus y. So the example, right? We see lots of example over here, right? We have already seen the example of MgCl2 and AlCl3, right? So obviously this is depending on what is the ratio. For example, MgCl2, right? CaCl2 MgCl2 is 1:2 or 2:1, means what is the ratio of anion to cation. Okay, right? So these are the examples that we have already discussed, right, everyone? Tell me. 1:3 type, which is AlCl3. Okay, so for this 27 s to power 4, right? So it is always 27 s to power 4. Okay, everyone? Okay, very good. I hope everyone is clear about this. Everyone is clear about this. Yes, if everyone is clear about this, then try to find some more. Okay, try to find KSP for some more salts, right? Let's see. I'll give you a reaction. Try to find KSP for this reaction. Al2SO4 whole thrice. It will break down into, tell me, 2Al3 plus 3SO4 2 minus, right? Write down the KSP for this one. What would be the KSP for this one? Tell me, everyone, what would be the KSP of this one? Everyone should say. Take it slow, don't worry, right? Step by step, follow the procedure step by step, right? 2s, 3s, KSP. Yes, very good. I'm getting answers. Very good, Avas. Step by step. 2s whole power 2, 2 into 3s whole power 3, which is 4, 2 square into 27, 3 cube into s to the power x plus y, which is 2 plus 3. Right? This is the formula, right? Which is 108 s to the power 5. Got it, everyone? Tell me, got it? Everyone got this? Yes, Ovas. See, Karishma, right? When we talk about Al, so it is 2Al, so it is 2s and 3s. So concentrate KSP, as I said, KSP is equal to concentration of Al 3 plus to the power, sorry, to the power 2 into concentration of SO4 2 minus to the power 3, right, everyone? So concentration of Al3 plus is 2s, right? Or solubility is 2s, and solubility of SO4 2 minus is 3s, right? So 2s square into 3s cube will give you this. Okay, everyone, right? Okay. Okay, got it, right? So let's solve one problem, everyone. Let's solve one problem. Everyone, please solve this problem, right? Please try to solve this problem, everyone. So the solubility of KaF2, right, in water is given, which is 15.6 mg per dm cube, right? So obviously you have to convert into moles, right? So try to find it, everyone. Try to find it. I'll give you 2 minutes. Yes, I guess all of you have understood the problem. Try to solve this. So first, what is the molecular weight of CaF2? Tell me, what's the molecular weight of CaF2? Yes, Meet. Very good. Correct answer, Meet. What's the molecular weight of CaF2? Yes, Pranjal. Correct. Okay, very good. Okay, now see this. First of all, what is S? You have to find S, right? So see, what is S, everyone? So S, when you talk about S, right, which is solubility, okay, so it is 15.6 divided by its molecular weight because it's weight per liter. DMQ is liter. So weight per liter, W by L, whereas concentration is N by L. So you have to divide this by molecular weight, which is 78. So it is 2 into 10 power minus 4, right? S is given, solubility product, KSP is asked. So we know that is 1:2, which is 4S cube. As simple as that, right? Okay, just put the value, right? You will get the answer. Okay, everyone. Now try to find this one. Try to find question number this, everyone. Find it. Everyone try to find it. Is easy. This is what? This is, you're asked to find S. You're asked to find S, right? And KSP is given. Just see the ratio. It is 3:2, right? When you talk about 3:2, it is 3 cube into 2 cube, 2 square. As simple as that, which is 108. And you're asked to find S. So S is equal to what? KSP by 108 to the power 1 by 5. Remember, everyone? So see, what's the answer, everyone? Tell me, what's the answer? As simple as that. It is formula putting getting yes or yes. Very good. The answer is B. Right, everyone? The answer is B. These things should be on your tip. Okay, these things should be on your tip. Right? Okay. Now, what do you think? What can happen to this? So obviously, we can have common and effect also. Tell me yes or no. We can have common and effect also in this. So what will happen to common and effect? Just suppose we have a solute which is AB, which is breaking down into AB plus into B minus. Now just think about this. Just think about this. Right? I'm having another solute which is also having B, right? Which is C plus B minus. Now what do you think? We have already discussed common and effect, right? So I can say that this will be just as, tell me what, right? This will be just as the common and effect that we have studied before, right? Okay, now this is your strong salt which will dissociate completely. Okay, so it will have CC. So what is the new concentration? Just remember this using alpha alpha, na alpha dash, right? So now new concentration of B minus is alpha dash plus C, right? Just consider the value, right? Okay, now I can say that in this case, right, since S, right, or S1 is very less than C, okay, it can be ignored, right? It can be ignored. So we will have KSP as S1 into C. Okay, Now, if you actually think, if you go back and remember your concept, it is no different than the common effect of either weak acid and the salt, right? It's same. Yes or no? Tell me everyone, isn't it same? Tell me everyone, is it same or different? Is there anything else except the reactants, right? So we know that by common ion effect, if you remember, by common ion effect, right? Common ion effect, the degree of distillation was decreased. This was decreased. So obviously the solubility will also decrease, yes or no, because it is the same concept, right? Yes or no? It's a Leach-Astley principle only, right? So I can say that, right? The effect of common ion will be same, right? It will follow Leach-Astley principle and the solubility will decrease, okay, right? Now try to solve this one. Everyone try to solve this one. Question number 36. Everyone please try to solve this. Yes, very good, OS. Everyone, tell me. Everyone should say, right? Yes, Anisha, very good. Correct answer, Anisha. Sorry, correct answer, Anisha. Correct answer, right? Just think about this, right? Step by step, right? Yes, Meet, very good, correct. So M2X3 will give you what? 2M, tell me, 3 plus 3x 2 minus. So 2s and 3s. But it is given that solubility, right? N2X3 dissolved water that solubility is x gram per mole. It's given, right? Okay. Then easy, right? Yes, Vivek, very good. Very good. Easy. It's very easy. So the answer is C, right? Very good. Now try to solve question number 37, everyone, right? Try to solve question number 37. Sneha, screen is fine. Everyone, screen is blur. Is screen blur? Tell me. Tell me, everyone. Is the screen blur? I can see the screen clearly. Can you see the screen clearly? Sneha, it might be your internet issues. Okay. It might be your internet issues because screen is very clear. Okay. See, till I'm in Bangalore, I won't be having internet issues. Okay. So that's the thing, right? Okay. Okay, 37. Everyone, please try to solve question number 37 step by step. Again, this is based on common ion effect. Okay, so solve question number 37 using common ion effect. Okay, Mansi present now. Samya is absent. Very good. Meet correct. Pranjal correct. Okay, everyone. Right? Yes, the answer is A. Right? Yes, Pradyumna. Very good. Right? Right. Now let's see everyone how to solve this, right? Now this is your case of common ion, right? AgNO3, AgNO3 and AgCl. Now AgCl is given, AgCl solubility of AgCl is given, okay? And calculate solubility of salt in 0.1 molar AgNO3. So I can say that in this AgNO3 is acting as common ion, yes or no? Tell me. AgNO3 is acting as common ion, so concentration of Ag plus given by AgNO3 is 0.1, right? So now new KSP. Now KSP will be same only. It is concentration of Ag plus into concentration of Cl minus. Now if you see this, now this is very small. Yes or no? This value is very small. Agree everyone? KSP is very small, right? Right? Right everyone? Okay everyone? Yes? Very good. So you can just put, usually it should be this, usually it should be concentration of Ag from this plus S, okay, into S. But since this S is very negligible as compared to this A, it will be just 0.1 into S, right, which is KSP, right? Right, everyone? Agree? Okay, very good. So it is this divided by 0.1, which will give you A. I hope everyone is clear about that. Tell me, everyone is clear, right? Right, everyone? Okay? Okay, everyone. So I guess the concept is clear. Now let's try to solve one more problem. Okay, let's try to solve one more problem. One more type of problem. Try to solve this one. Everyone, try to solve this one. Question number 38. Tell me, everyone. Try to solve question number 38. Think about it and tell me. I'm giving you 1 minute. Now let's see this, right, everyone? Okay, everyone, let's see the step by step, how you approach, okay? Because some of you might not even understood the problem. Now see this, 0.1 mole sample of AgNO3 dissolved in 0.1 mole of NH3, right? Now just think about this, If AgNO3 will dissolve in H3, what will happen? So AgNO3 will give Ag plus, right? Right, everyone? Okay? Now, this Ag plus will react with NH3 to form a salt, which is AgNH3 whole twice plus. This is a complex salt. This is a complex salt. Okay. Okay, sorry, my bad, everyone. You could not have solved this because you should know the KSP of Ag and KSP of AgNH3 whole twice. So my bad. Okay. So this information should have been given, right? Okay. So my bad. Anyways, I'll just explain you how to solve. This information will be given. Okay, KSP will be given. So the reaction which I said, you should know this. Okay, right? Now if you know this reaction, Ag plus 2NH3 will give this. How you know this reaction? Using this concept, right? Using this information that there should be the formation of AgNH3 whole twice plus. Okay, right? Now we know that for this reaction, Kf is given by, tell me, this, it is given, it will be given. Now concentration of AgNH3 whole twice plus, okay, concentration of Ag, right, is 0.0, wait, yeah, 0.01, okay, 0.01, because this will be consumed, this is a limiting reagent, yes or no, right, this is a limiting reagent, right? So NH3 will form how much? 1 minus 0.02 because it is 1:2 ratio, right? Which is 0.8. So this is a bit rearranged. So I'll just write the reaction again for you guys. So Ag plus 2NH3. Step by step, everyone will give Ag NH3 whole twice whole plus. This is a complex salt. Okay, complex salt. So initially it is 0.1. This was 1. This was 0. At equilibrium, right? Now, this will be consumed. Technically, this should consume completely. Okay, right? So technically, it is 0 for this reaction. Think about it. Technically, it is 0 for this reaction. I'll tell you. I'll explain each and every reaction. And this will be 1 minus 0.2. And this is 0.1 ratio. 1:2:1. Okay, but what now? Now this salt, right? 0.01 mole of NaCl is added to the solution, right? So again, when 0.01 solution is added, right, it will again form some Ag plus. So that's why that Ag plus, the common is Ag plus over here, will be X. That's why I have taken as X, right? And here it will be ignored. Right? It is ignored here. Again, common ion. So I can say that Kf, which is given for this reaction, is concentration of AgNH3 whole twice, which is 0.1. Now, you could have written it as 0.1 minus X, okay, but that would be ignored, okay, because the value of X is very small, right? Now, divide by concentration of NH3 whole twice, which is 0.8 whole squared into concentration of Ag plus, which is X. Can you find X from here? Tell me, everyone, can you find X from here? Yes or no? Have you understood this? Tell me, have you understood this? Because this is a salt, right? If this will react with NaCl, right, it will form what? It will form AgCl plus NH, right? Salt of Na. Okay. So if you solve this, you will get Ag plus as this one. Now you know the concentration of Ag plus. You know concentration of Ag plus. You know concentration of Cl minus, which is given, right? Multiply them. If it is greater than KSP, which is also given, right? Then it will precipitate. If it is less than KSP, it will not precipitate. So after multiplying, we will get this value, which is less than KSP. Hence, it will not precipitate. Okay, everyone? Tell me, understood? This one was one of the good questions of the solubility. Okay? Tell me, yes or no? Yes or no? Did you get it? Just raise your hand if you get this concept. Just raise your hand. Okay, everyone, very good. right? So I hope all of you got this. Okay. Okay, everyone, right? So that was the concept of solubility. Let's see some concept test. Now try to solve this. You all might have stirred a salt water solution to dissolve the common salt in it. So can you say that stirring a solution affect the solubility of salt in a solution? What's the answer? Okay, think about it. Think about it. Why you stir? Right? Everyone think about it. Okay. Okay. Everyone, please respond. Everyone should respond. Right? Don't be shy. So the answer is B. No. Right? Just think about it. I've told you, right? I've told you, right? Okay. The solubility will not change. Okay, the only thing which will change it will dissolve faster. Right, everyone? If you remember what you have done, okay, it will only dissolve faster. Right, everyone? It doesn't change the amount, and solubility is the amount. Right? Solubility is the amount which is dissolved. Yes or no? Understood the concept? Tell me, everyone, raise your hand. Did you get the concept now? Very good, everyone, right? Okay, let's see the concept of precipitation, fractional precipitation that we have already studied, right? Effect of common and effect and pH insolubility. Now, we will talk about pH insolubility, okay? Right, we'll talk about pH insolubility. This one, tell me, this concept test. Tell me, everyone. Think about it and let me know. Everyone should think. Okay, so most of you answered your question. Let's see what's the answer. The answer is C, right? Statement 1 is true and statement 2 is false. Now let's see this, right? Let's see this. Why this answer statement 1 is false? Now think about it. Think about it, right? Wait, what's the answer? I guess answer is 1 is true and 2 is false, right? Yeah, so 1 is true and 2 is false. Now think about this. Na2SO4, does it have anything to do with AgCl? Tell me. Na2SO4, will it have any effect on AgCl? Right? So obviously I can say that the solution is saturated with respect to Ag present Cl minus, not Na2SO4. Yes or no? Yes or no? Right? If I would have given Ag, right, to SO4, if I would have given Ag2SO4, then the question would have been different, right? But I'm giving Na2SO4. The ions present in Na2SO4 is completely different from AgCl. So it will not have any effect on AgCl, and it will dissolve until the new equilibrium is reached with respect to this. Okay, everyone? That's why the statement 1 is true, okay, and statement 2 is false. Right? Next one. Next one, try to think about this one. Use the concept of normal common ion and your chemical equilibrium and Lee-Chasles principle. As simple as that, right? Nothing else. Guys, yes, what's the answer? Tell me. Think about it. Now, guys, let's see. Like, let's see. When talk about solubility, it is basically S, right? Okay. Now, when talk about solubility of hydroxide, think about this. Fe3 plus is coming from where? FeOH को whole thrice. So the concentration of Fe3 plus will be how much? It is 4 into 10 to the minus 20, right? Right, everyone? And when you talk about concentration of OH minus, this is coming from both this and this, right? Yes or no? Because this OH minus is coming from both this one and this one. But when you talk about solubility of ferric oxide, you should take OH minus from Fe OH whole thrice, yes or no? Tell me, right? So OH minus from Fe3OH whole thrice should be equal to this, right? 3 into 10 to the minus 20. Yes or no? Tell me, yes or no? Yes or no? Tell me, everyone, right? So when you talk about solubility, it is S only, right? It is S only. So S should be equal to this, which is the answer should be B. Got it, everyone? Tell me, got it? Yes or no? Yes or no? Because you're talking about S, you're not talking about concentration of OH. Okay, right? See this. Everyone just go through this. Okay, right, everyone? So I hope all of you understood the concept. Yes, very good, everyone. Very good. Now let's see some more problems. Okay, right? Let's see some more problems based on your solubility and solubility product, right? Okay, let's see this. So when you talk about the concepts, right? The concepts that we have covered here is what is solubility product and what is ionic product. Now, how any solubility product is calculated for given salt, right? Condition required for precipitation and the effect of common ion, right, everyone? Let's see step by step. This we have already studied. These things we have already studied, everyone. I hope all of you remember. Okay. So, okay, this was common ion. This was for common ion. Let's try to solve some problems. Okay. So question number 1, I guess all of you can solve question number 1. We have already discussed. Question number 1 you can solve. Right? Try to solve question number 2. Everyone try to solve question number 2. Okay. This is very good problem. Question number 2 is very good problem. Okay. Try to solve question number 2. It is a good problem. So try to solve by yourself. Okay. I'll give it 2 more minutes. Okay. Let's see. We have 30 milliliter of 1 molar AgNO3. So number of moles of AgNO3 we have. This is equal to 30 into 0.1. Got it? Right? Which is number of moles of Ag plus. As simple as that, right? Again, 90 milliliter of 0.06 molar K2Cr2O7. So number of moles of K2Cr04 is also 90 into 0.06. Let's see, this is 3 and this is, tell me how much? 5.6, I guess, right? Okay, so 5.4. Right, everyone? Got it? Now, predict whether the precipitation of Ag2Cr04 will occur or not. Now, when you talk about concentration of, when you talk about this reaction, when you talk about the reaction of AgCrO4, think about it. Ag2Cr04. This will give what? It will give Ag2Ag plus CrO4 2 minus. Agree, everyone? Tell me. Agree? Yes or no? Just raise your hand. Yes or no? So Ksp is equal to concentration of Ag plus whole square into concentration of CrO4 2 minus, right? Now, this is given, this is actually given, which is 1.9 into 10 to the power minus 12, right? So just have to find Q, you just have to find Q, which is concentration of Ag square into concentration of CrO4. Now, we know that concentration of Ag plus is equal to number of moles of Ag plus, which is 3, divided by volume. Now this is 3 millimoles, by the way. So volume is 90 plus 30, which is 120, right? Again, it is milliliter, so it will be cancelled, right? So if you observe, you can get the concentration. You can get the concentration of Ag plus and CrO4 2 minus, multiply them and just check that if it is greater than Ksp or less than Ksp. So here, if you observe, it is greater than Ksp, so yes, precipitation will occur. Right, everyone? Now let's see question number 3. Everyone, let's try question number 3 step by step. Everyone understood question number 2? Tell me, everyone understood question number 2? Question number 3, everyone, step by step. We have solved this question, by the way. If you remember, we have solved this question, only the data is changed. Okay? Think about it, everyone. Think about it. Step by step, right? Write down what is given. Concentration of Ag plus from AgNO3 is 0.01, right? Ksp of AgCl 1.5 into 10 power minus 10. Molecular weight of AgCl. Okay. Now we know that Ksp is equal to concentration of Ag plus into concentration of Cl minus. As simple as that. Now Ksp is given 1.5 into 10 power minus 10. Concentration of Ag plus, due to common ion, it will be just 0.01 into S. As simple as that. You have to find S. Can't you find S? Tell me. Can you find S? Yes or no? Right? Got it? Tell me yes or no. Yes or no. Okay. So I hope all of you got this concept. Right, everyone, just raise your hand if you got the concept of this. Just raise your hand. Okay, very good, everyone. Very good. Okay, so we will play Kahoot. Today we will play Kahoot, okay? Right? So have we played any Kahoot of Ionic equilibrium? Tell me. Just message me. Have we played any Kahoot of Ionic equilibrium? Yes. One. Okay. We have played one, right? The basic one. The first one. Okay. So today let's play the hydrolysis one and the solubility one. Okay. Okay, everyone, please join. Okay, I'm starting it. So let's see. The first question is weak acid Ha, right, and weak base BUH, right? The pH of the aqueous solution. Now, this is just formula putting getting. Just formula putting getting. Tell me, everyone, right? Formula putting getting. As simple as that. If you remember the formula, this question should be easy. I didn't remove anyone's Sneha. Okay, Abhiram. Just try to solve it, everyone. Try to solve it. Okay. 20-second left. Ten seconds. 17 answers till now. Everyone should solve. Everyone, right? Or at least try to solve. Okay. Very good. So this was just formula putting getting. pH was what? Half into pKw plus pKa minus pKb. Right, everyone? Tell me yes. So pH was half into 14 plus 4.8 minus 4.78. Okay, right? So it will be how much? 14.02 by 2, which is 7.01. That's the answer. Formula putting getting. Right? Right, everyone? Okay, next. The pH of a solution at 25 degrees centigrade contain 0.1 molar sodium acetate, okay, and 0.3 molar acetic acid, right? pKa of CH3COH is. Think about it, everyone. Think about it. This much time you will get in NEET or KCET, by the way, right? Only this much time. Okay, again, formula putting getting. What is this? You have to ask, what is this? What is this mixture, right? Then just use the formula. This is what I was talking about in last class. It's not about the problem is difficult or easy. It's about how you approach it. Okay, only 16 answers. Very good. So see, sodium acetate and acetic acid. Weak acid, salt of weak acid. Tell me what it is. What it is. Tell me, everyone. What it is. Message in the chat box. Buffer. What is the formula of buffer? pH is equal to pK plus log. Tell me. Salt by acid. Yes or no? Yes or no? right? So pH is equal to pKa, which is 4.57 plus log salt by acid, which is, tell me, 0.1 divided by 0.03. Okay, right everyone? Tell me, so can you calculate? Yes? Okay everyone. Next, a certain buffer solution contain equal concentration of X minus and HX. The Ka for solution is given. What is pH? Very easy question, you should answer within seconds. Very easy question, you should answer within seconds. If you revise the concept, 15 seconds left everyone. Guys, this is easy problem, right? You should not take that much time. Okay, I got 21 answers. Very good, right? So this is pH is equal to pKa only because it is your ideal buffer. Yes or no? Log x minus by hx. So this is equal, so it is log 1, which is equal to 0, right? So this is the case of ideal buffer in which the pH is equal to pKa. Okay, right? Very good. Next, which of the following is not a buffer? Again, very easy question. It should be answered within few seconds. Okay, just look at it. Okay, everyone, 13 seconds left, 12 seconds, 19 answers till now. Okay, let's see. Let's see the answer. Yes, very good. Most of you said the correct answer. Very good, everyone. Right? Yes. Okay. You just have to observe. You just have to observe weak acid, right? Or weak base and their salt. Okay. Okay, everyone. Next. In a buffer solution containing equal concentration of B minus HB, the Kb, again, this is very easy, super easy question. Same as question number 3. Same as question number 3, everyone. Same as question number 3. Don't be hasty, by the way. Don't be hasty, right? The answer is to find pH. Okay, Viram. Very good. Everyone just, and only 4 students. Guys, you guys were hasty, right? We know that POH is equal to pKb plus, right? Plus log salt by base. Yes, yes, Aviram, including you 5 student, right? B minus by HB. Okay. So obviously it is 10, 14 minus 10, which is 4. Okay. No issues, Sneha. Just you have to practice on the concept, right? It's just for practice, revision, nothing else. In which of the following aqueous solution is the degree of dissolution of water maximum? Tell me. Degree of distillation of water maximum. Think about it. Conceptual problem. Okay. Think about it, everyone. Okay. Just think about the component. What are they? Right? What are they? Salt, 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 salt. What type of salt? That's it, right? Then you will get your answer. Okay. Okay, Sneha. Okay, Viram. Very good. Let's see. 10 seconds left. 18 answers till now. Yes, C. Right? Just see this now. Weak base plus strong acids, salt. Weak acid plus strong base. Strong acid plus strong base. And this is weak acid plus weak base. So tell me, in which case the hydrolysis will be maximum? Obviously, in case of C, right? So obviously, if hydrolysis is maximum, right? So H water will dissipate maximum. Yes or no? Yes or no? Simple concept, right, everyone? Next, let's see the scoreboard. Very good. It has been changed. Shilika and Pradyumna are in top 5 now. Let's see, 7th one. When the salt of weak acid and weak base is dissolved in water, the pH of the solution will always be, again, just a concept, right? Just a concept. Very easy problems. Everyone should solve it, right? I guess I need everyone's answer in this, and everyone should have the correct answer. This is very easy. We have discussed this in last class itself. Last class, I mean. What happened? Something happened? It depends on KKB, na, right? Yes, it depends on KKB because it is half PKW plus PKA minus PKB. Depends on PKB. If this PKB is equal to 0, then it is 7. If it is greater than 0, then it is 7 plus something. If it is less than 7, then it is 7 minus something, right? So it depends on PK and PKB. Okay, now let's see next one. The hydrolysis constant of salt with NO2 minus ion is, right? K is given. Okay, tell me what's the answer? You have to find hydrolysis constant. K is given. Easy question, everyone. Formula putting getting, as simple as that. Formula putting getting, everyone. Okay, very good, Aviram. Yes, okay, most of you got it correct. It is KW by KA, as simple as that, right? KW by KA, very good, Sneha. Okay, very good. Second last question, everyone. What will be the pH of aqueous solution of 1 molar ammonium formate? Formula putting getting. Again, we discussed this formula in question number 7, I guess. Very good, Aviram. Very good, Sneha. Correct answer, everyone. This is easy question, everyone. Formula putting getting, right? So this is CET and NEET level questions. Okay, these kind of questions are CET and NEET level questions. But these are the concepts that will be difficult, right? That will leads to wrong answers in JE also, because in JE also they won't ask very difficult problems. You just have to remember the correct formula and you need to understand what the question is. Okay? Yes, Aryan, very good, correct. Right? So maximum student gave correct answer. Very good, everyone. What about who gave wrong answer? Half PKW, which is 14, plus PK, which is 3.8, minus PKB, which is 4.8, which is 13 by 2, which is 6.5. Right? Guys, those who are having correct answer, sorry, wrong answer, please check your concept. Last question, everyone. Last question. What is the hydrolysis constant of OCl minus ion? The ionization constant is 3 × 10⁻⁸. This question we have discussed already. Okay. Okay, Abhiram. Okay, Sneha. Everyone, please answer. Okay, Aryan. 20 seconds left, everyone. 20 seconds left. Okay. Now the answer is yes, as most of you guessed, 3.33. Yes, Pradyuman, right? B. I've told you, right? I've told you because when we solved this, it was a mistake in concept test. I told you that it was this problem or the problem like this wasn't concept test. I told you that this was wrong. It is opposite reciprocal, right? Yes. Let's see the podium, everyone. Let's see the podium. Third, Malik. Very good, Malik. Second, Meet. Very good, Meet. First, who's first? Aryan. Very good, Aryan. Fourth, Chulika. Fifth, Riya. Very good, Chulika and Riya. Very good. Yes, Abhiram. Obviously, you would have been first if you would have said the correct answer. Okay. So actually, it's Abhiram. Anyways, thank you, everyone. Thank you for today's class, right? So I hope all of you will solve uh, all the exercise because we have time till Monday. Okay, right? And as I told you, I will take 3 revision tests. Okay, on Sunday, right? It will be a revision test. So just revise. Okay, one in physics, one in chemistry, one in maths. Okay, so I'll just take from the recent chapters only. Okay, from recent 2-3 chapters. So it is a revision surprise test. Okay, bye everyone. Take care. Bye everyone.